this video we will discuss the inverse function test for equations. Let's say that you have two equations and you would like to know if those two equations are inverse functions of each other. In other words, does one function do exactly the opposite of the other? We use what we call the inverse function test. What we're going to do is compose the functions together both ways. So this idea is composition. And when we compose the functions together both ways, the result should be exactly x. If we get out exactly x, no more, no less, then the functions are inverses. Alright, we're not saying that the function results after the composition have to match. If one is negative x and the other one is negative x when we do the compositions, just because they match does not make them inverse functions. We're not saying that they have to match. What we're saying is that they have to be exactly x. Both of them have to be exactly x. If one is something other than x, then they are not inverse functions. Alright, so we're being very specific, exactly x for both. Let's talk about really quick as to why this makes sense that the inverse function test would give us exactly x. One thing we want to kind of reiterate here is that functions that are inverses are the opposites of each other. So let's say, for example, that we're going to create a machine. Let's say you have a machine that starts with some cherries. And you're going to put a cherry into this machine, and what this machine does is that it covers in chocolate. So it takes whatever you have in this machine, let's call this the function f of the machine. It takes whatever you put into it, doesn't matter what it is, takes it, put it in, and covers it in chocolate. So out on the other side would come a chocolate covered cherry. Okay, so let's say that's our chocolate covered cherry. If we have a machine that does exactly the opposite of that, what would that be? Well, the opposite would be to remove chocolate. So in a sense, it uncovers. So what would I get? So if I took that result and I took that chocolate covered cherry and I removed the chocolate, we would get right back to where we started. So when both functions are done, then you would end up exactly where you started. You could also do it in the opposite way and say, well, what if you had, let's say you started out with a chocolate covered cherry and you ran it through the machine that would uncover the chocolate, so it would take all the chocolate off. And then you said, well, let me do function f. Then you would end up right back where you started. Function f would cover it in chocolate. And then you would end up back where you started with a chocolate covered cherry. So it doesn't matter which function you do first. If you do one and then the other, you should always end up right back where you started. So the idea here is that if you, let's say you start with x, and then you do something, and then you do exactly the opposite, what you're going to end up with is, again, right back where you started, you're going to end up with x. So if the functions are undoing each other, when you put something into the functions and you do both functions, then you should end up right back where you started. So in a sense, that's what's happening here. We're putting some x value into the function, into the composition. G does its thing and then f does its thing, so they're both working. And then if we get out exactly x, what we're saying is if we started with an x at the beginning, we'll end up with exactly that same x value at the end. So what does this test actually look like? Well, we're going to find the composition of f and g both ways, and then we're going to see if we get out exactly x for both. No more, no less. Exactly x. So let's start here. We have two functions, f of x equals 7x plus 4, and g of x equals x minus 4 divided by 7. We would like to know if these functions are doing exactly opposite things from each other. Are they inverse functions? So we have two equations and we want to know if they're inverse functions. We will perform the inverse function test. So what that means is that we are going to compose, we're going to do that composition. We're going to compose the functions together both ways. So we're going to do f composed with g, and then we're going to do g composed with f. And our goal for both of them is very specific. Our goal is exactly x. If we don't get out exactly x as a goal for both of those, then they are not inverse functions. Alright, so when we do composition, we said the first thing that we would do is we would put x into g. Well, that seems kind of silly. If I put an x into g, I get x minus 4 divided by 7. So that was kind of the silly non-first step that we talked about with function composition. Okay, well after I put an x into the inside function g, I get out x minus 4 divided by 7 as a result. Then I'm going to take that and I'm going to put that into the outer function f. So if the function f is 7x plus 4, I'm going to put parentheses everywhere I have an x. And I'm going to take that x minus 4 divided by 7, and I'm going to drop that in to the parentheses. Now I want to simplify this. We have 7, we can think about that as 7 over 1 if we want to, times x minus 4 divided by 7. When I'm multiplying two fractions together, I can cancel common factors in the top and the bottom. So let's cancel those 7s. I'm left over with x minus 4, and then I have that plus 4 that's going to come down. X minus 4 plus 4, well, plus 4 and minus 4 are going to cancel each other out. Minus 4 plus 4 is 0, and I end up with exactly x, and that was our goal. So we have met the goal for the first composition. Now, in order to say they're inverses, we have to compose them in the other order, and we want to get exactly x again. So, for this composition, we put x into f first, which is, once again, kind of silly, because if I put an x into f, then I get this equation. We already know what that looks like. We already know what that is. That's 7x plus 4. Now we're going to drop that result into the outer function. So I'm going to write function g. Now function g is x minus 4 divided by 7. Okay, so there's that outer function. I'm going to drop in this 7x plus 4. And I'm going to start to simplify. I don't have any multiplication here. Really all I have is addition and subtraction. So x plus 4, plus 4 and minus 4, those are going to cancel each other out. So I end up with just 7x at the top divided by 7. The 7s will cancel each other out because 7 divided by itself is 1. I end up with 1 times x, which is just x. Once again, we have met the goal. Our goal was to get out exactly x for both compositions. So the conclusion is, once we've met the goal for both compositions, we can say that f and g are inverse functions. Alright, and that is our what we call our inverse function test. Alright. So the next example, we have two functions and we want to know if they're inverses. So our goal is to do the composition both ways. And the result from each composition, we want very specific goal of just x. We don't want anything else, just x. That's our goal. So step 1 for composition, we put an x into g, and that's kind of silly. We know what it looks like when we put an x into function g. We get x plus 3 divided by 5. Okay, so step 2 then would be to say take that result and drop it into that outer function. The outer function is 3x minus 5. So I'm going to put parentheses everywhere I have an x, and now I'm going to drop the result from the last step into the parentheses. So in this case, when I think about 3 over 1 as a fraction and I look to multiply those two fractions together, the 3 and the 5 are not going to cancel each other out. So the best that I could do to perform the multiplication would be to multiply across. We get 3x plus 9 divided by 5. 1 times 5 is 5. Minus 5. And this is not x. When we look at the result of that composition, we do not get x. So we got 3x, was that plus 9, divided by 5 minus 5. We did not achieve our goal. So goal not met. Remember, our goal was to get out exactly x, not all of that junk. So we don't have to perform the second test. We can say that f and g are not inverse functions. So remember, our goal is not to have the results match. The goal was for each composition to get out exactly x, no more, no less. So once we do that first composition and we get something other than x as a result, we can stop, goal not met. They are not inverse functions.